In the grand tapestry of the cosmos, the most profound changes often begin with the quietest of dances, a slow, inevitable spiral toward a destiny written in the laws of gravity long before we were here to witness it. Perfection in the universe is a rare and fragile thing, yet it is the imperfections, the wobbles, the eccentricities, and the strange, non-conforming paths that reveal the true nature of the hidden clockwork. Tonight, we find ourselves looking toward the distant, velvet reaches of the southern sky, specifically toward the constellation of Centaurus, where the air is thin and the stars seem to shiver in the cold, expansive dark. It is here, billions of light-years away from the comfort of our sun, that a singular event recently sent a tremor through the very fabric of reality. A story that began with a neutron star and a black hole locked in an orbit that defies our usual expectations of celestial harmony. This cosmic encounter, a collision of unimaginable density and darkness, was not a perfect circle, but a jagged, oval-shaped descent that whispered secrets of how stars are born, how they die, and how they sometimes find one another in the loneliest corners of the void. The vastness of space is often described as a vacuum, but to those who listen with the right instruments, it is more like a resonant chamber holding the echoes of ancient violences. We must imagine the silence of a laboratory in the deep of night, where the only sound is the rhythmic hum of cooling systems and the soft, steady ticking of a wall clock, marking time as data streams in from the Laser Interferometer Gravitational Wave Observatory. It was within this stillness that a signal arrived, a faint, rhythmic chirping that had traveled across the eons, carrying the news of a catastrophic union. This was not a sudden explosion in the way we understand fire or light, but a warping of space itself, a ripple in a pond that had finally reached our distant shore. The investigation into the signal, later identified by the designation GW230529, revealed a pairing that should not, by traditional accounts, have been quite so lopsided or quite so eccentric. A neutron star is a remnant of a once great sun, a ball of matter so dense that a single teaspoon of its surface would weigh as much as a mountain range. We can picture it as a glowing, humming sphere of pure nuclear energy, spinning with a frantic, desperate precision. Its partner in this final dance was a black hole, a region of space where gravity has become so absolute that not even light can find its way out. Usually, when such giants meet, they have spent millions of years smoothing out their orbit into a perfect, predictable circle, losing energy as they spiraled inward. But this pair was different. They moved in an oval, an eccentric path that suggested their meeting was not a slow courtship, but perhaps a forced encounter in a crowded stellar neighborhood. According to the data, this oval orbit acted as a signature, a frantic heartbeat that quickened as the two objects swung close to one another and then slowed as they drifted apart before the final, inevitable plunge. The study of this event allows us to unwind the history of the stars themselves. At the time of the collision, the neutron star was likely being torn apart by the immense tidal forces of its larger companion. As we look closer, we see the beauty in the physics, the way the black hole's gravity reached out like invisible fingers, stretching the neutron star into a thin ribbon of glowing matter before consuming it entirely. This process, known as tidal disruption, is a quiet, heavy affair when viewed from the perspective of the cosmos. There is no sound in space, only the fading glow of radiation and the deep, resonant ring of gravitational waves that tell us something has been lost. The stillness that follows such an event is profound, a return to the natural equilibrium of the dark, leaving behind only the ripples that we, in our small corner of the universe, are just now learning to read. By the next morning, as the researchers analyzed the chirp of the gravitational waves, they realized they were witnessing a rare glimpse into the mass gap, a mysterious range of weights where stars are too heavy to remain neutron stars, but seemingly too light to be the black holes we typically find. The black hole in this oval dance was small, only a few times the mass of our Sun, making it a celestial oddity that challenges our understanding of how stars collapse. It is a reminder that the universe does not always follow the neat, tidy boxes we build for it. Instead, it drifts into these strange, eccentric spaces, creating scenarios where giants collide in ways that feel almost accidental, yet are governed by the same heavy, unyielding laws that keep our own feet on the ground. The investigation into the oval echo is still ongoing, a process of sifting through the digital echoes of a tragedy that happened before our world was even a thought. It is a narrative of process rather than shock, a slow uncovering of facts that helps us feel a little more connected to the vast, cold horizon of the deep. As we sit here in the warmth of our own world, the memory of that distant neutron star serves as a mundane anchor, a reminder that even the most violent events in the universe eventually settle into a quiet history. The data has been recorded, the papers have been written, and the mystery of the oval orbit has become another chapter in our collective knowledge, a story of how two lost souls in the dark finally found one another and became one. According to the reports, the signal has now faded, leaving the region of Centaurus as quiet as it was before. The ripples have passed us by, continuing their journey into the infinite, while we remain here, safe and undisturbed by the giants that roam the dark. The shadows of the room seem to lengthen, echoing the stillness of the void, and the heavy eyelids of the world begin to close. We can take comfort in the fact that these celestial movements, while grand and powerful, are part of a historical record that is now settled. The universe has tucked this secret away, and as the light of the distant stars continues to drift toward us, we find ourselves ready to let go of the questions and embrace the silence. As the echoes of the oval echo fade into the background of the cosmic hum, we find ourselves looking toward another part of the sky, where the cold winds of the interstellar medium tell a different story. Just as the stars of Centaurus have settled into their new reality, we travel now to a different pocket of the deep, where the silence is not born of a collision, but of a long, lingering wait. Would you like me to describe the strange, rhythmic pulses of the first pulsar ever discovered, and how its discovery once made us believe we were finally being spoken to from the stars? In the vast, velvety silence of the deep cosmos, there exists a specific kind of patience that we, with our fleeting moments and ticking clocks, can scarcely imagine. We find ourselves drifting now toward a corner of the universe where gravity does not merely pull, but breathes in a slow, rhythmic cycle. Here, the vacuum is not empty. It is a canvas of subtle vibrations, a celestial gallery where the most extreme remnants of stars engage in a long, winding dance. Imagine a pendulum, carved from the densest matter imaginable, swinging across an invisible arc that spans millions of kilometers. This is the realm of the great oval, a trajectory that defies the typical circular grace we expect from the heavens. In this quiet expanse, we observe a neutron star, a sphere no larger than a city, yet heavier than our entire sun, and its companion, a black hole of modest but absolute darkness. They are locked in an eccentric embrace, tracing an elongated path that resembles a stretched teardrop. At the furthest point of their journey, they linger, almost still, as if hesitant to return to the center. Then, the weight of their mutual attraction begins to pull them back. They accelerate, sliding down the long slope of spacetime, gaining momentum until they whip around one another in a close, intimate pass. It is during these brief moments of proximity that the cosmic pendulum reaches its peak intensity, sending out ripples that travel across the light years like the softest hum of a distant bell. The atmosphere here is one of profound, heavy equilibrium. We might think of the neutron star as a lighthouse, spinning with a precision that makes our best chronometers seem erratic. Its surface is a crust of iron and exotic crystals, glowing with a heat that is softened over eons into a steady, comforting radiance. Beside it, the black hole is a well of perfect stillness, an anchor in the dark that provides the pivot for their long, oval journey. There is no violence in this movement, only the relentless, reliable mathematics of the universe unfolding in real time. We see the way the light from distant galaxies bends and warps as it passes near them, creating a shimmering halo that guides us deeper into the story. As they continue this cycle, we begin to notice the subtle synchronization of their movements. Every time they draw near, they exchange a silent greeting, a transfer of energy so delicate it would take 1,000 lifetimes to notice the change. They are drifting closer, yes, but with a grace that suggests they have all the time in the world. The space between them is filled with a faint amber glow, the ghost of gas and dust trapped in their shared gravitational field, swirling like steam rising from a cup of tea on a cold winter night. We watch as the pendulum swings again, the heavy weight of the neutron star falling toward the dark center, only to be carried back out by its own momentum, beginning the long, slow climb once more. It is a process of refinement, a thinning of the veil between motion and rest, leading us toward a moment where the two will finally become one, merging their ripples into a single, eternal wave that carries the memory of their dance into the infinite. We are taught that the dance of the cosmos follows a perfect circular grace, a predictable clockwork of spheres, but deep in the silent reaches of space, two shadows have just broken the rules. In the grand tapestry of the heavens, we often find comfort in the idea of celestial orbits as steady, unyielding rings, much like the ripples on a still pond or the steady rotation of a grandfather clock in a quiet hallway. Yet, far beyond the light of our own sun, an eccentricity has been discovered that challenges our understanding of gravitational harmony. We find ourselves observing a neutron star and a black hole locked in an oval orbit, a stretched and elongated path that defies the standard expectations of general relativity. This eccentricity anomaly suggests a history far more complex than a simple rhythmic convergence. Instead of the circular paths we expect to see as objects lose energy through gravitational waves, these two titans trace a sharp elliptical route, swinging close in a breathless brush of density before drifting far apart into the cold dark. This is not a chaotic crash, nor is it a violent disruption that threatens the stasis of the galaxy. Rather, it is a long-period synchronization, a slow-motion alignment occurring over millions of years, far removed from the fragility of our world. As we watch this distant ballet, we can imagine the space-time fabric not as a place of fire and fury, but as a vast velvet sheet. The black hole and the neutron star move like invisible depressions across this fabric, two warped wells of gravity that do not collide so much as they lean into one another, year after year, century after century. The air in our own world remains still, the scent of cedar and the soft hum of the evening air grounding us, while out there, the vacuum of space holds this strange, oval secret. This discovery invites us to rethink the clockwork of the universe. It suggests that even in the most extreme environments, there is a lingering memory of the star's origins, perhaps a kick from a supernova or a chance encounter in a crowded stellar nursery, that keeps the orbit stretched and lingering. We are merely observers to this ancient, patient process, watching as the oval slowly, ever so slowly, begins to soften, though it will take eons before the circle is finally closed. For now, the two shadows continue their eccentric journey, drifting through the stillness of the deep. The interaction between these two celestial titans is not merely a visual dance, but a profound exchange of physical properties that challenges our understanding of matter under extreme pressure. As the neutron star begins its closest approach to the event horizon, the space between them becomes a theater of invisible, violent forces that remain strangely silent to the human ear. The neutron star, a sphere roughly the size of a city, but containing more mass than our Sun, is encased in a crust of crystalline iron, a structure so dense that a single teaspoon of its material would weigh billions of tons on Earth. This rigid shell is not immune to the black hole's influence. As it enters the strongest part of the gravitational well, the tidal forces begin to pull at the star's poles, stretching the sphere into a subtle, elongated teardrop. This is the beginning of the engagement, a phase where the star's very foundation starts to hum with a frequency that resonates through the fabric of spacetime itself. Within this crystalline crust, the atoms are packed so tightly that their electrons have been crushed into the nuclei, creating a sea of neutrons that flows with zero friction. This superfluid interior reacts to the black hole's proximity by forming tiny swirling vortices, thousands of microscopic whirlpools that move in perfect synchronization. The energy generated by this internal friction is released as a soft thermal glow, a dim light that flickers against the absolute darkness of the companion. There is a heavy, rhythmic quality to this process, much like the slow, deliberate ticking of a grandfather clock in a hallway where the shadows are long. Each pass through the periapsis, the point of closest contact, shaves a microscopic layer of energy from the orbit, a tax paid to the curvature of space. The investigation of these pulses allows us to map the interior of the star, revealing a landscape of nuclear pasta, where matter takes on shapes resembling long ribbons and thin sheets, all held together by the strongest forces in the known universe. We find ourselves observing a transition that is both majestic and inevitable, a slow unwinding of physical potential that will eventually lead to a singular, transformative moment. The stillness of the surrounding vacuum serves as a stark contrast to the churning complexity within the star's core, a reminder that even in the deepest reaches of the cosmos, there is a meticulous order to the way things fade. The two companions are now locked in a grip that cannot be loosened, their fates tied to the geometry of the oval that guides them through the dark. The universe has a profound, almost obsessive love for the circle. In the quiet textbooks of our youth, we are taught that gravity is a patient sculptor, smoothing out the jagged edges of motion until every binary dance becomes a perfect, rhythmic loop. This is the circularization of orbits, a process where the constant shedding of energy through gravitational waves acts like a celestial sandpaper. Over millions of years, the chaotic lunges of two stars are supposed to settle into a predictable, round embrace. We find comfort in this symmetry. It suggests a cosmos that seeks balance and stability. It is a mathematical grace that tells us where things are and where they will always be. Yet the signals reaching our sensors from the deep void have begun to tell a different story, one that challenges the very foundation of this orbital perfection. When the laser interferometers of LIGO and Virgo captured the faint, rhythmic stretching of spacetime from a distant collision, the data did not show the steady, rising hum of a circular merger. Instead, there was a distinctive, unsettling wobble, a modulation in the frequency that felt less like a song and more like a desperate, uneven heartbeat. This was the signature of eccentricity, a deviation from the circle that should not have survived the long journey toward a merger. In the language of the architect, we define this strange oval through the value of eccentricity, denoted as E. While a perfect circle sits at 0, these two objects, a black hole and a neutron star, were locked in an orbit where E exceeded 0.1. To the uninitiated, this may seem like a minor decimal, a small rounding error in the vastness of the dark. But to those who map the stars, it is a glaring impossibility. It suggests that these two were not born together in a slow, cooling cradle. Instead, they were likely thrown together by a violent external force, perhaps in the crowded, bustling heart of a globular cluster where stars jostle like commuters in a station. As we look closer at this geometry, we feel a sense of profound awe. Our best models, the ones we have polished for decades, suddenly appear like simplified sketches, unable to capture the true complexity of a universe that refuses to be tidy. The oval is a reminder that the vacuum is not a vacant stage, but a place of dynamic, often jagged encounters. This elongated path means the neutron star spends most of its time drifting in the cold distance before screaming inward, accelerating to incredible fractions of the speed of light as it brushes past the black hole's event horizon. It is a high-stakes game of celestial chicken, played out in the silence of 1 trillion miles, where the geometry itself reveals a history of chaos that we are only just beginning to read. The investigation into this impossible shape reveals a cosmic truth. The stillness of the night is often a mask for a much more restless reality. According to the data, this eccentricity is not a flaw in our instruments, but a window into a part of the cosmos where the rules of the perfect circle are brazenly ignored. We are forced to wonder what else we have missed by assuming the universe prefers the simplest path. By the time the signal faded, it had left behind a map of a journey that was as beautiful as it was irregular, a testament to the fact that even the most rigid laws of physics can be bent by the right kind of history. As the gravity of this realization settles over us, we find ourselves looking toward the smaller of the two companions, a speck of matter so dense it defies the imagination. To understand the companion in this celestial dance, we must first contemplate the death of a giant, a process that is less an ending and more a radical, violent transformation of state. For millions of years, a massive star maintains a delicate, glowing equilibrium, its internal nuclear fires pushing outward with enough ferocity to hold back the crushing weight of its own immense gravity. It is a graceful stalemate that defines the life of every sun in the cosmos, but for those stars with 8 to 20 times the mass of our own, the fuel eventually runs thin and the fire begins to falter. When the outward pressure finally ceases, gravity, patient, relentless, and absolute, wins the battle in a fraction of a second, causing the stellar core to implode at nearly 1/4 of the speed of light. This is not merely a collapse of structure, but a collapse of the very building blocks of matter itself, as electrons are crushed into protons to create a solid sphere of neutrons. The resulting object is the neutron star, a remnant that challenges our most fundamental definitions of what it means to be solid or heavy. We might try to visualize its surface, but the word surface feels inadequate for a crust of iron atoms compressed until they lose their individual identities, becoming a lattice of nuclei submerged in a superfluid sea of neutrons. This outer shell is harder than any diamond, polished by gravity to a smoothness that allows for mountains no taller than a few millimeters, yet those tiny ridges weigh as much as the Himalayas. Below this crust, the density increases until we reach a state of matter so exotic that it behaves more like a single, giant atomic nucleus than a collection of separate particles. To truly grasp the scale shift at play here, we must leave behind our earthly intuition and embrace the impossible. Imagine, if you will, the entire mass of our sun, a sphere so large that 1,000,000 Earths could fit inside it, squeezed down until it occupies a space no larger than the island of Manhattan. In this realm, the laws of biology and geology are overwritten by the laws of quantum degeneracy. A single teaspoon of this star's material would weigh roughly 1,000,000,000 tons. It is the weight of an entire mountain range condensed into a grain of sand, a reality so heavy that it warps the very fabric of space and time around it. Standing near such an object, the pull would be so intense that even the light reflecting off the back of the star would be curved toward your eyes, allowing you to see both sides of the sphere at once. It is a city-sized anchor of pure, distilled mass, drifting through the dark with a gravitational footprint that far exceeds its modest physical dimensions. As we settle into the stillness of this realization, we begin to feel the sheer, tangible weight of the star, a silent, spinning testament to what happens when nature is pushed to its absolute limit, waiting for the moment its path crosses with something even more profound. The darkness of the void is rarely truly empty, but here, in this specific corner of the cosmos, the silence is anchored by a presence that defies the very definition of being. We find ourselves drifting toward the dark partner of this celestial dance, a black hole of modest yet formidable proportions. It does not announce itself with the blinding fusion of a star or the frantic spinning of a pulsar. Instead, it exists as a puncture in the fabric of spacetime, possessing a mass roughly 5 times that of our Sun, compressed into a volume so minuscule it effectively ceases to have a physical surface. This is the Schwarzschild radius in its most elegant and terrifying form, a mathematical boundary where the escape velocity required to leave exceeds the speed of light itself. There is no wall here, no jagged edge or rocky crust to mark the transition from the universe we know to the abyss. The event horizon is a ghost, a point of no return, woven into the vacuum. To an observer, it is merely a sphere of absolute ink, a shadow cast against the distant, twinkling tapestries of far-off galaxies. Yet, within this boundary, the laws of physics as we understand them begin to unravel, surrendering to a gravity so absolute that time itself seems to stretch and stall. The black hole acts as a silent gravitational anchor, its influence reaching out through the cold distance to claim its smaller, denser companion. The relationship between these two is one of profound, inescapable intimacy. They are connected by an invisible thread of gravity, a bond that defines every microsecond of their shared existence. As they spiral, the black hole's immense pull does not allow for the comfort of a perfect circle. Instead, it stretches the neutron star's path, tugging it into a signature oval orbit that pulses with a rhythmic tension. With every pass, the neutron star is drawn dangerously close to the dark threshold before being slung back out into the cold reaches of its eccentric loop. This orbital tug is a silent conversation between two titans, one a city of hypercompressed matter, the other a void of infinite depth, locked in a geometry that will eventually lead to their final, violent union. According to the laws of celestial mechanics, this oval dance is a countdown, a slow erosion of distance that brings the point of no return closer with every sweeping curve. The investigation of such a pair reveals a stillness in the center of the chaos, a place where the heavy influence of the black hole ensures that nothing, not even light, can ever truly drift away. As the next phase of their descent begins, the surrounding space becomes a laboratory of extremes, where the vacuum is no longer empty, but filled with the invisible weight of a partner that refuses to let go. The transition from the absolute vacuum of deep space into the gravitational influence of the binary pair marks a shift in the very fabric of the local environment. We find that the space between these two titans is not a void, but a medium of diluted energy and stretched geometry. At the time of their closest approach, the neutron star begins to feel the first gentle tugs of tidal forces, a subtle stretching that begins at its poles and radiates toward its equator. According to the laws of general relativity, this is where the density of the surrounding field begins to thicken, though it remains invisible to the naked eye. The investigation of these forces reveals that the black hole does not simply pull, it curves the path of its companion into a descending spiral that defies the circular perfection we often expect from the heavens. Not long after the initial capture, the neutron star's own intense magnetic field begins to interact with the warped spacetime created by the black hole, creating a shimmering, silent friction in the dark. By the next morning of this cosmic timeline, the orbit has shifted from a distant glide into a more intimate, oval descent. This phase of dilution is characterized by a strange paradox. The distance between the two objects is shrinking, yet the physical matter of the neutron star remains intact, held together by its own crushing gravity, even as the black hole tries to undo it. Identified as a period of medium density, this stage of the journey allows us to observe the play of light as it bends around the massive pair. The starlight from distant galaxies behind them is smeared and stretched, creating a halo of distorted images that drift across the horizon of the black hole. We see the soft glow of the neutron star, a crust of iron and crystalline structures, reflecting the absolute nothingness of its partner. It is a quiet, heavy dance, where the stillness of the void is replaced by the rhythmic pulse of two hearts of matter beating in a confined, darkening room. The silence is profound, yet the energy being traded between them is enough to power 1 billion suns, all held in a delicate, temporary balance. As the neutron star continues its drift, the atmosphere of the local system becomes heavy with the scent of crushed atoms and the invisible weight of destiny. The stillness that once defined this region of the galaxy is now a memory, replaced by a deep, vibrational hum that resonates through the very structure of the universe. We observe the way the light begins to fade as it is swallowed by the growing shadow of the black hole, a shadow that seems to reach out with invisible fingers to stroke the surface of the neutron star. The investigation into this phase suggests that the matter within the star is beginning to settle, preparing for the final, inevitable dilution into the singularity. According to the records of the stars, this is the moment of quiet reflection before the chaos of the final descent begins, a time to appreciate the resilience of matter before it is unmade. Not long after, the first whispers of gravitational waves begin to ripple outward, carrying the news of this meeting to the farthest reaches of the cosmos. By the next morning, the oval path has tightened once more, drawing the two closer into a bond that can never be broken, ensuring that their story will remain etched in the silence of the night forever. The memory of this encounter remains a testament to the patient power of the universe. In the deep shadows of this binary system, the danger has already passed into the realm of history, leaving behind only the fading echoes of a journey well traveled. We can rest now, knowing that the heavy influence of these giants is far removed from our quiet corner of the world, where the ticking clock and the warmth of the evening air provide a grounding sense of peace. The stars above continue their slow, rhythmic drift across the sky, undisturbed by the distant dramas of the deep. You are safe in the stillness of the present, where the shadows are long and the horizon is soft. The investigation is complete, the path is clear, and the quiet beauty of the cosmos remains a protective canopy over your sleep. All is well, all is still, and the night is yours to find rest within. The vastness of the cosmos is rarely a place of accidental meetings, yet we find ourselves considering the rare mechanics of a chance encounter in the deep. To understand how a black hole and a neutron star come to dance in such a strange, elongated oval, we must look away from the idea of a shared childhood. In the standard story of the stars, these two would be siblings, born from the same cloud of gas and collapsing in tandem. But the evidence suggests a different history, a more nomadic beginning. This is the theory of dynamic capture, a concept that posits these two objects were born in entirely different corners of a crowded galactic center, drifting through the dark as strangers for eons. The galactic center is a dense, bustling neighborhood of ancient remnants, where the gravity of 1,000 suns tugs at every passing shadow. In this crowded theater, the black hole moved with a silent, heavy authority, while the neutron star, a dense pearl of nuclear matter, traced its own solitary path through the void. Their meeting was not a gentle merging, but a cosmic near miss, a moment where the laws of motion and the heavy hand of gravity conspired to bind them together. However, for two such fast-moving travelers to suddenly halt their journey and enter an orbit, a third party was almost certainly involved. Imagine a third star, perhaps a mundane and unsuspecting sun, passing through the same patch of space at the precise moment these two giants cross paths. As the black hole and the neutron star pulled toward one another, the third star acted as a gravitational catalyst. In a violent exchange of kinetic energy, this third inhabitant was likely kicked outward, flung into the lonely reaches of the galaxy, and in that sacrificial moment, it drained enough energy from the remaining pair to lock them into their current, eccentric embrace. This interaction is what pushed their orbit into that distinctive, stretched oval, a permanent scar of their turbulent introduction. We might compare this capture to two lonely travelers meeting on a vast, dark highway in the middle of a winter night. They did not set out together. They did not know of each other's existence until the very moment their headlights swept across the same stretch of asphalt. There is a profound sense of shared curiosity in this realization, a human impulse to wonder about the origins of things that seem so perfectly joined now, yet were once so disparate. We look at this binary system and see a partnership, but it is a partnership born of a chaotic coincidence in a cold, indifferent space. It reminds us that even in the most desolate reaches of the universe, there are forces that bring the solitary together. As we study the trajectory of their oval path, we are really tracing the history of a handshake between strangers. The investigation into their past reveals a universe that is not just a clockwork machine, but a place of unexpected meetings and sudden, permanent bonds. The stillness of the night remains unbroken as we contemplate these two travelers, now forever linked, drifting together toward a horizon we are only just beginning to understand. We must consider the medium through which these celestial bodies move, not as an empty void, but as a heavy, viscous fluid that responds to every motion with a silent, rhythmic pulse. Imagine, if you will, a vast lattice of invisible silk stretching across the entirety of existence, a lullaby lattice that cradles the stars and the darkness between them. As the black hole and its neutron star companion trace their eccentric, oval path, they do not merely pass through this fabric, they stir it, creating a specific chirp in the very foundation of reality. This is the gravitational wake, a series of ripples that propagate outward like the soft rings on a midnight pond, carrying with them the story of a collision that began long before the light ever reached our eyes. The oval orbit is not a static loop, but a dynamic, breathing entity that bleeds energy into the surrounding universe with every pass. Each time the neutron star swings close to the dark heart of its partner, it pushes against the curvature of spacetime, and in that exertion, a small portion of its orbital vitality is surrendered to the vacuum. We find that the system is slowly shrinking, the oval drawing tighter and more circular as the energy escapes into the distance. It is a slow, methodical winding down, a cosmic clock losing its tension as it radiates its presence across the light years. If one could stand upon the shore of this gravitational sea, the sensation would not be one of sound, but of a profound, tactile vibration. It would feel like a low-frequency hum vibrating through the soles of your feet, a deep thrum that resonates within the chest, mirroring the steady heartbeat of a universe in motion. This vibration is the signature of their union, a rhythmic flow that lulls the observer into a state of hypnotic reflection. The waves are heavy, moving with a deliberate grace that suggests the infinite weight of the objects that birthed them. Not long after the first ripple is felt, the mind begins to drift with the frequency, unwinding from the frantic pace of the day and sinking into the stillness of the deep. The investigation of these waves reveals a universe that is constantly whispering to itself, sharing the news of its shifting horizons through a language of pure geometry and motion. By the next morning of our understanding, we realize that this wake is the only true record of their journey, a fading echo that tells us they were here, they were together, and they were moving toward a final, silent embrace. The fabric of spacetime remains a fluid mystery, a soft, dark ocean where even the heaviest shadows leave a trail for us to follow. As we watch the oval shrink, we see the beauty and the loss, the way the universe claims its due from those who dare to dance in its depths. The movement is slow, the energy bleed is patient, and the horizon continues to beckon with a quiet authority that ensures nothing is ever truly lost, only transformed into the hum of the night. Would you like me to describe the tidal distortion that begins to take hold as the neutron star is pulled into a silent, terminal stretching? The gravitational wake has settled into a rhythmic, almost hypnotic pulse, and we now find ourselves observing a transformation that defies the rigid nature of matter. In the popular imagination, we often speak of spaghettification, that violent vertical stretching that occurs when an object falls into a black hole. But here, in this wide and oval orbit, the process is far more subtle and lingering. It is not a sudden snap, but a tidal deformation, a silent stretching that occurs every time the neutron star reaches its periastron. This is the point of closest approach, the moment when the two titans are nearly touching, and the black hole's gravity begins to tug more fiercely on the near side of the star than the far side. We watch as the perfect sphere of the neutron star, a dense ball of matter the size of a city, begins to elongate into a soft, glowing egg shape. The star does not yield easily. It is held together by the strong nuclear force, a fundamental resistance that fights back against the cosmic pull. There is a profound tension in this struggle, a microscopic war between the gravity that seeks to unravel the star and the internal pressure that seeks to maintain its integrity. It is a drama played out in the vacuum, devoid of sound, witnessed only by the cold light of distant galaxies. We can almost feel the sensation of being pulled and then released, a rhythmic inhalation and exhalation of spacetime itself. As the star swings away from its dark companion into the wider arc of the oval, it relaxes, pulling its matter back into a sphere, only to be distorted once more upon its return. This cycle of distortion is a heavy, patient process, an academic display of physics where the equations fade into the background, leaving only the sight of a celestial body being molded like clay. The neutron star remains a silent witness to its own alteration, drifting through the shadows of the horizon, while we remain here, safe in the stillness of the night, watching the slow-motion dance of a titan that is being ever so gently undone. The persistent nature of this oval journey suggests that we are not merely watching a two-part play, but rather a more complex arrangement where a silent guardian watches from the wings. It is a common truth in the vastness of the cosmos that what appears to be a solitary pair is often part of a much larger, more intricate family. Astronomers have begun to look past the immediate glow of the collision to find the ghost star, a third, distant companion that sits far on the horizon of this system. This distant partner, though it never touches the black hole or the neutron star, acts as a gravitational anchor, a heavy hand that prevents the orbit from ever smoothing out into a perfect circle. We find a certain comfort in the presence of this third body, as it explains the mathematical stubbornness of the oval. Without it, the laws of physics would have demanded the orbit relax, but this silent watcher exerts a subtle, constant pressure, ensuring the strange geometry remains intact. This phenomenon is governed by what we call the Kozai-Leadov mechanism, a gravitational dance so slow and patient that it feels more like a drifting tide than a violent force. In this hierarchical triple system, the distant star and the inner pair exchange a quiet energy, a trade of angular momentum that keeps the eccentricity high. It is as if the third star is guarding the oval, pushing back every time the inner two try to settle into a simpler, rounder path. We can imagine the gravitational lines between them like invisible threads, pulled taut and then released in a cycle that lasts for millennia. This mechanism resolves the intellectual knot that had previously puzzled the observers. It provides the safe knot that justifies why the system hasn't reached a peaceful equilibrium. The paradox of the oval is thus resolved not by chaos, but by a deeper level of order. According to the data gathered by the investigation, this hidden influence ensures that the neutron star continues its rhythmic approach and retreat, never fully escaping and never fully settling. The stillness of the deep space surrounding them is deceptive, for it hides this complex interplay of three hearts beating in a synchronized mathematical pulse. There is a profound relief in discovering this hidden hand, a sense of safe curiosity that allows us to watch the collision not as a mistake of nature, but as a masterpiece of celestial mechanics. As the night deepens, we see that the strange oval is held in place by a loyalty of gravity, a commitment between three bodies that will not be broken until the very end of their shared time. This hidden influence, this steadying presence of the third star, allows the narrative of the collision to unfold with a predictable, heavy grace, ensuring the shadows of the horizon remain exactly where they were meant to be. The silence of the deep cosmos is not a void, but a heavy, velvet curtain that is finally drawn closed over the frantic energy of the initial encounter. We find ourselves drifting into a state of profound stillness, where the violent potential of the black hole and the neutron star has softened into a low-frequency hum. At this stage of the descent, the density of events thins out, replaced by a vast, cooling expanse that stretches toward the horizon. The once jagged edges of the gravitational data have smoothed into a long, slow curve, much like the fading embers of a fire that has long since stopped leaping. Every movement in this oval orbit is now deliberate and weighted with a sense of inevitability. The instruments that once spiked with urgency now record a steady, rhythmic pulse, the heartbeat of two titans resigned to their shared path. In the quiet of the observation deck, one might imagine the smell of ozone fading, replaced by the neutral, clean scent of sterilized air and the soft clicking of a cooling processor. The light from distant, unrelated stars flickers with a steady, comforting reliability, casting long, dim shadows across the consoles. This is the phase of deep sleep, where the chaotic physics of the third body influence have settled into a predictable, drifting grace. The data streams have slowed to a trickle, providing a much-needed reprieve for the mind to wander through the history of this celestial pairing. By the next morning of our observation, the pair has traversed another silent arc of their elliptical journey. The investigation of their trajectory reveals no sudden deviations, only the persistent, lulling pull of gravity. It is a process-oriented reality now, where the how of their eventual union is written in the fading echoes of their orbital resonance. There is a profound peace in this lack of news, a historical certainty that the danger has passed into the realm of recorded fact. We watch as the shadows of the neutron star stretch across the event horizon of its companion, a slow-motion dance that requires nothing more from us than our quiet presence. The heavy stillness of the sector remains undisturbed, a testament to the enduring laws that govern the dark. We are safe in the knowledge that this story, while grand in scale, is one of steady resolution and fading light. The horizon remains fixed, the stars remain constant, and the drift continues toward a quiet, inevitable conclusion. As we linger in this low-density space, we feel the weight of the universe pressing gently against the glass, inviting a rest that is both deep and earned. Would you like me to describe the final, fading signatures of their orbital decay as they prepare for the ultimate transition? The orbital ballet has entered its most deceptive phase, a period of time where the clock of the universe appears to wind down until the ticking is almost imperceptible. We are observing the million-year drift, a long and sweeping curve where the black hole and the neutron star are locked in a gravitational embrace so tight yet so vast that movement itself feels like a form of stillness. As they draw nearer, a strange paradox of physics takes hold. Though they are moving at speeds that would defy our earthly comprehension, the sheer scale of the void makes their progress feel like a slow-motion descent into a dream. It is a deceleration of the spirit. We watch as the neutron star, a dense pearl of nuclear matter, traces an eternal path around the shifting shadow of the black hole, each lap taking lifetimes, each inch gained a testament to the patient persistence of gravity. There is a profound cosmic pause in this region of space, a silence that is not merely the absence of sound, but the presence of an ancient, heavy peace. Between the moments of highest gravitational tension, there is only the drift. We find ourselves floating in the atmospheric textures of this dark sea, where the light from distant galaxies is stretched and pulled into long, shimmering ribbons. The curve of their path is graceful and deliberate, a soft arc that maps the geometry of the invisible. It is here that we transition from the act of learning about these giants to truly experiencing the weight of their existence. We feel the sweeping motion of the stars as they pass by, the shadows of the past falling away as the two bodies prepare for a union that has been written in the stars since the beginning of time. This is the era of the long shadow, a time when the universe seems to hold its breath. The energy being radiated away in gravitational waves is constant, yet the change is so gradual that the system appears frozen in a state of perpetual approach. We observe the fine details of the neutron star's surface, the way its intense magnetic fields flicker like a candle in a drafty room, casting a dim, rhythmic glow against the absolute blackness of its companion. It is a scene of immense philosophical awe, reminding us that in the grand tapestry of the cosmos, a million years is but a single heartbeat, a brief moment of reflection before the final, inevitable convergence. The tension is there, hidden in the mathematics of the spiral, but on the surface there is only the quiet, rhythmic pulsing of a universe at rest, drifting toward a conclusion that is as beautiful as it is certain. Under the soft light of a billion distant suns, the two travelers continue their march, tracing a path that is both a destination and a journey, lost in the shimmering, silent elegance of the deep.